Alright, here we go. We are going to work on factoring the GCF. Let's review a couple of things, please. One, factor is a verb. This verb means to rewrite what we are given as a product. I like to remind myself or think about it as factor is a direction to unmultiply. What do I mean by this? Here's an example of a problem that I've already worked. I've taken this red problem and distributed the 3x to the binomial inside. I've taken my two factors and multiplied them to make an answer or a product. What we are going to do in our process is to work from the product back to the factors. We're going to undo the multiplication. All right? So, the other point I want to remind you of or make very, very clear is that the greatest common factor is something that we do first. This is always first. I have a couple of other notes here. Expressions, they do not have an equal sign, so you cannot solve them. You can simplify them, you can manipulate them in some way, but you cannot solve them. Equations, however, they do have an equal sign, and so that you can solve them. Let's return to the topic of GCF, greatest common factor. I'm going to use this example here. We're going to take the greatest common factor. We're going to take the greatest common factor. Take it just means to actually perform this action. I'm looking at this, 2x squared plus 6x. I notice that each has an x term. I also notice that each number can be divided by 2. So what I'm going to do, I'm actually going to do that. Divide each part by 2 and by a single x. Only one x for this whole entire phrase, because even though this part of it can divide by x squared, this part does not have enough x's to be divided by that and create an integer value or a whole value. So we will record the 2x that we are dividing everybody by. If this matches, I will record it out front of this binomial set. Then I will take this division problem and write its result here. I know 2x squared divided by 2x leaves me with just a single x. I will then take this division problem and write its result in the back. Positive 6x divided by 2x leaves me a positive 3. In this particular case, I am finished now. I notice that the expression in the front right here is the GCF. So if I were asked what is the GCF of this expression, it would be the 2x. If I were told to factor it, I would write down this entire expression here. And we are finished. Now, it is possible to check, and it's actually a really good idea. It catches many mistakes. If I were to take my result that I came up with, 2x squared, multiplied to x plus 3, and I were actually to multiply it out like we're normally used to doing, I would get 2x squared, and I would get positive 6x, and I would see that this part here matches my original problem, and I would know that I got it correct. That's one way of finding it. Let's proceed with other questions or other problems and see how we do. This particular problem we've already done. I want to look at problem number 2. I notice that each of these values can be divided by 5. So that's what I'm going to start with. I also notice that each of these terms has an x value. So I can divide with an x, but the question is how many x's? Well, I can divide this by x cubed, 3 x's, but this doesn't have enough. I can divide this by x squared, but this doesn't have enough. So I need to go with the smallest quantity, and that's just 1x. The fact that this and this and this all match means I have found the greatest common factor. Inside the parenthesis, I write the results of the individual division problems. 5x cubed divided by 5x leaves simply x squared. Negative 10x squared divided by 5x leaves a negative 2x. And then 5x divided by itself leaves 1. And in this particular case, because we're only finding the GCF, we are finished. Here is the GCF. Now it is possible at times that this interior part might be able to further factor, but that's not the focus of this lesson here. We might later on be able to defactor this green section more, but not today. We're not doing it today. Look at number 3. I see that each of these is divisible by the value of 3. I notice that this last term has no x's, so I will not include x. But what I do notice is, in particular, this first term is negative. I'd like to get that to be positive. I see that I can divide all of them by a negative 3. So I'm going to. So, negative 3 is the GCF. Once I divide, I will end up with a positive x squared. If I divide here, I will end up with a positive 5x. And in the back, I will end up with a positive 6. And because we're only looking for the GCF, we are finished. I do say again, it might be possible that this here is further factorable, but again, we're only looking for the GCF in this particular case. I would like to talk about another, or I should say a second way to check to see whether or not I've actually factored this correctly. We'll use this in future. Here's my calculator. What I've done is I've pressed the y equals button, and I've typed in this first line, y1, the original problem for number 3. Let me bring this over here where you can see it. So I've taken this negative 3x squared minus 15x minus 18 and typed it in the first y1. I've taken what I've produced by my factoring process and typed it in the y2. If I have done it correctly, then these will produce identical values. I'm going to press second graph. I'm looking at the table of values. This is y1. This is my first, or I should say the problem, the original phrase I was given. y2, if you remember, is what I created. That's this section down here. I see that I have matching values between these two tables, between these two lists. I know by that I am, in fact, factored correctly. Another process could be to actually have this graph, and I will notice that I will have created one picture. This first drawing is the original problem, and in fact, I apologize, it's difficult to see because it's all in the same color. On your calculators, you will actually see a red and a blue line drawn on top of each other. That's why I kind of prefer looking at the tables. Let's continue. The expressions are a little more complicated this time. I see x squared t cubed minus r cubed t squared added to x t to the 4th. I initially noticed that each of these has the value of t. I also notice that the smallest quantity of t's is square, so that's what I can divide with. And that's all. So I know my greatest common factor is going to be t squared. What I will then do is complete each division, and I will get x squared t minus r cubed added to x t squared. And I'm finished here. All right. The next problem, I chose it on purpose because sometimes it might not be immediately obvious what I'm supposed to divide with. You can try various numbers, but the goal is to find the greatest factor, the greatest common factor that we can, and to do it quickly. So if it's not very obvious, if it's not that obvious, what I would recommend you do is to divide by the smallest value. Now in this particular case, our values that I'm discussing are 12, 16, and 28. Obviously 12 is the smallest, so I'm going to try to divide each of these terms by 12. It will definitely work. 12 divided by 12 is 1. The problem is here. 16 divided by 12 does not produce a whole number. So, if it does not work, if not, the next part would be step 2, would be to factor the smallest value, then divide with the factors that you created. Divide with the factors. Let's see what I mean. So, I have myself a workspace here. In this workspace, I'm going to factor apart the smallest value. I'm going to factor apart the 12. So, what values would multiply and give me 12? Starting with 1 multiplied to 12. 2 multiplied to 6. 3 multiplied to 4. And this will be all of them. It's a good idea to find them all. I want to start with the greatest. So I already know that 12 is the largest one, and I tried 12, it didn't work. 6 would be next. 6 will divide into 12, giving 2, but 6 will not divide into 16, so that's out. 4 will divide into 12, giving 3. 4 will also divide into 16, giving 4, and 4 will divide into 28, giving 7. So this, in fact, is the term or the value that I want to divide by. Let's go ahead and use it. Dividing by 4, dividing by 4, dividing by 4. Let's check for variables. X cubed, x squared, y, x. They all have the value of x. The most I can use is 1x, so I am finished. I have found my greatest common factor. Let's record that out front, and then we continue with the division to fill up the parenthesis, which would leave us 3x squared on the first term, minus 4xy, followed by 7y squared. And in this particular case, again, we are finished only because we were given the direction find the GCF. In later times, we will have to look at this inside quantity to see could we continue, but for now we are finished. All right? Number 6. Yeah, number 6. 7c squared minus 17c minus 70. First off, I notice that this last term has no variables, so I can't divide with any letter at all. Secondly, I notice that 7 will not divide into 17, so this has no GCF. All right. Please practice this process. Recall that the GCF is only the first part of this factoring process. Many times we'll have to follow a second or a third part or process to completely factor the expression we are given. This is only the beginning. We will learn additional factoring processes, subsequent factoring processes in the following videos. Thank you.